Hi everybody, in this video we're going to do some word problems involving the different trig ratios. So I highly recommend that when we're working on these word problems that you have a piece of paper out so that way you can practice setting up the diagrams and solving them before we go over them together on this video. So I do recommend that you pause the video, take some time to read the question, think about it, and to try it yourself before you unpause and watch how it's actually done. I also recommend that you read the question 3 times before getting started. The first time, just to understand what the question is talking about. The second time, to try to interpret the question and get a sense of what math is going on in it. And the third time, to get important information or details like specific numbers out of the question. So it's always a good idea to read the questions 3 times whenever you're approaching word problems. Okay, so we're going to get started on this first one. So we have a 25-foot ladder that's leaning against the side of a house. So here is my house, and here is my 25-foot ladder, right over here leaning against the side of the house. The base of the ladder, that means the bottom of the ladder, is 12 feet from the house on ground level. Find to the nearest degree the measure of the angle that the ladder makes with the ground. So here's the ladder, here's the ground. So this is the angle that we're looking for in part A. So here I have a right triangle. So from the angle that we're looking for, this would be the hypotenuse, and this would be the adjacent leg. We have adjacent and hypotenuse. Let me write my SOHCAHTOA in the corner. That lets me know I'm going to be using cosine adjacent over hypotenuse. So cosine of the angle that we're looking for is equal to adjacent over hypotenuse. Remember, anytime we're solving for an angle, we do need to cancel out the trig function. So we're going to solve using inverse trig. So the inverse of cosine is inverse cosine. And if we take inverse cosine of our cosine ratio, it will give us the angle that we're looking for. I'm going to type this into my calculator. Second, cosine, the COS button, in the parentheses 12 over 25. And the question says to round to the nearest degree. That means the nearest whole degree. So the angle that we're looking for is approximately 61 degrees. Now I'm going to move on to part B. And in part B, it's asking us to find to the nearest foot, so that means the nearest whole foot, whole number, the distance from the top of the ladder to the ground. So we're looking for the distance from the top of the ladder to the ground. So we're looking for a side of our right triangle. So from our focus angle, this side would be opposite. So we are looking for a trig ratio that uses opposite and adjacent or opposite and hypotenuse. Either one would work. I'll use opposite and adjacent. So that would be tangent. So tangent of our focus angle is equal to opposite would be x over adjacent would be 12. Since we're solving for a side, we can cross multiply. So we have 12 tangent of angle theta is equal to x. And we already found what this angle was in part A. We found that it was approximately 61 degrees. I'm just going to replace the unknown over here with what the angle actually is, because we do know that it's 61 degrees from part A. I'm going to plug this into my calculator. 12 tangent button TAN 61 in the parentheses, and I'm going to hit enter. And it does say to round to the nearest foot. I got 21.6. So x is approximately 22 feet. So I found that this is approximately 22 feet. And yes, you could also solve using the Pythagorean theorem, because we already did have two sides of this right triangle and we needed to find the last side. I just wanted to practice setting up and solving a trig ratio here to find the side. But if you do have two sides of your right triangle, you can use Pythagorean theorem to find the last side. Just make sure that you plugged in 25 in for C, because the hypotenuse does need to always go in for C in the Pythagorean theorem. Here we have another example, so feel free to pause the video to try it yourself. So a submarine starts on the surface of the water and dives at an angle of 13 degrees. So here's my submarine, and it's on the surface of the water to begin with, and it's going down, it's diving at an angle of 13 degrees. It goes diagonally a distance of 890 meters before reaching the bottom. So here is the ocean floor, the bottom. I'm going to write here bottom. And here's my right triangle, because remember, trig ratios can only be used for right triangles. So your diagram should end up looking like a right triangle. Sorry for that. My angle does not look like it's inside my triangle, so I'm just going to fix that so it's neither. That was my 13-degree angle right over there. How deep is the water where the submarine reaches the bottom? So for part A, we want the depth. So that would be how far down the submarine traveled. So here for part A, I want to find from my focus angle, this would be opposite, this would be hypotenuse, and this would be adjacent. So I'm looking for adjacent, and I have hypotenuse. So adjacent over hypotenuse is cosine. So I'm going to use cosine of angle 13 is equal to the adjacent leg over the hypotenuse. I'm going to put this over 1 and cross multiply. I have 890 cosine of 13 is equal to x. I'm going to plug this into my calculator, 890 cosine of angle 13. And it does say to round to the nearest thousandth. That's 3 decimal places. So x is approximately 867.189 meters. Now, part B is asking us how far is it along the ocean surface from the point where the submarine started to the point directly above where it reached the bottom. So from here to here, that's the same thing as from here to here. That's the same length. So I'm going to label that y because I already labeled this side as x. So we're really finding the opposite side of the right triangle from our focus angle. So I'm finding opposite, and I already had the hypotenuse. So opposite over hypotenuse is sine. So I'm going to use sine here. Sine of angle 13 is equal to opposite. That's what we're trying to find. Over the hypotenuse, that's 890. I'm going to put this over 1 so we can cross multiply. 890 sine of 13 is equal to y. Let me plug this into my calculator. 890 sine of 13. Oops, I typed that in wrong. Let me try that again. There we go. And I got that y is approximately 200.206 meters. So that's to the nearest thousandth. Here are some important things when you're working on word problems. The angle of elevation is when you're standing on the ground and you're looking up at an object. It's the angle at which you're looking up at the object at. The angle of elevation is always inside the right triangle. And in fact, it's always located in the same spot. So if the question tells you that you have the angle of elevation, it's always inside the right triangle next to the 90-degree angle. The angle of depression is when you're standing up higher than something and you're looking down at an object that's below you. So it's the angle at which you're looking down at an object. And just like the picture over here shows, the angle of depression is always located outside of the right triangle in the same spot. So whenever you have a question about angle of depression, you know automatically it's outside of your right triangle. And you might be wondering, that's not helpful. How is that helpful? Since when we're using trig ratios, we need angles that are inside the right triangle. So the angle of depression and the angle of elevation, which is right here, are actually congruent because they are alternate interior angles. If I highlight our parallel lines and our transversal, you can see that backwards letter Z. They are alternate interior angles, so they're congruent. So if you know the angle of depression, you automatically also know the angle of elevation, so that can get you more information about your right triangle to help you set up your trig ratio. Please take a minute and pause the video so you can read the question and try it out. The top of a lighthouse T is 215 feet above sea level. The angle of depression, so that's outside the right triangle, from the top of the lighthouse to a boat is 26 degrees. And that's already filled in for us, but notice how it's the angle that you're looking down at the boat from the top of the lighthouse, and it's located outside of the right triangle. Determine to the nearest foot the horizontal distance x from the boat to the base of the lighthouse. So we need an angle to focus on inside the right triangle. And remember, our angle of depression and angle of elevation are congruent alternate interior angles. So now I have my focus angle. So from my focus angle, this side would be opposite. Here's the hypotenuse. So here would be adjacent. So I have opposite and I'm looking for adjacent. That would be tangent, O over A, opposite over adjacent. So tangent of the 26-degree angle is equal to opposite over adjacent. So I can put this over 1 and cross multiply. X tangent 26 is equal to 215. I got to get that x by itself. So I'm going to divide both sides by tangent of 26 degrees to cancel it out. Let me type this in my calculator. It does say the nearest foot, so that's the nearest whole number. So I have 215 divided by tangent of 26. And I got x is approximately 441 feet if I'm rounding to the nearest whole foot. Moving along. This one's a little bit complicated, so please pause the video so you can read the question and try it out yourself. So what we need to do is we need to figure out how far the ship traveled from point A to point D. So we're looking from here to here. We're given the angle of elevation from the ship to the lighthouse at the first time that was mentioned. And we're also given the angle of elevation from the boat to the lighthouse at the second time that was mentioned in the question. So what we need to realize here is that trig ratios only work for right triangles. In this diagram, we have two right triangles. We have the whole big right triangle here, and we also have the smaller right triangle over here. But keep in mind, this smaller triangle on the left is not a right triangle. So you can't set up a trig ratio with this triangle over here to find AD because it's not a right triangle. So instead, what we can do is, since the red triangle is a right triangle, maybe we can find this side. And since the big blue triangle is a right triangle, maybe we can find this side of it. And we can subtract 2 so we can find AD, which is what we're actually looking for. So in order to do that, we're going to need two different trig ratios. We're going to need one for the small red triangle and one for the big blue triangle. Let's start with the big triangle, big blue triangle. So we have our focus angle, the 7 degrees, and I have the side that's opposite from it. And I'm looking for the leg that is adjacent. So let me set up a tangent ratio that's opposite over adjacent of the 7-degree angle. And that's equal to 125 over, I'll just call this x because I'm solving for it. Let me put this over 1 and cross multiply. So I have x tangent of 7 is 125. Then, if I divide both sides by tangent of 7, so I can get x by itself, I have x is equal to 125 over tangent of 7. I am not going to be putting it into my calculator and rounding it. I'm going to round it to the very last step because sometimes rounding early can really mess up your answer to the question. Now let's go to the small triangle, so the small red triangle. And I'll call the side that we're finding y because we already used x. So our focus angle is 16. We have opposite, and we are once again looking for the adjacent leg to the 16-degree angle. So that's tangent opposite over adjacent. So tangent of the 16-degree angle is equal to opposite. It's the same opposite side over adjacent, which I'm calling y this time. Let's cross multiply. I have y tangent of 16 is equal to 125. Then I'm going to divide both sides by tangent of 16 to get the y by itself. So y is equal to 125 over tangent of 16. Now, to get the side AD that I'm actually looking for, I'm going to do x, which is the side of the bigger triangle, that was AC, minus y, which was the side of the smaller triangle, DC. And that will leave us over AD, which is what we're looking for, from point A to point D, that distance. So x, I'm going to do this in my calculator because I have to do x minus y. So x was 125 over tangent of angle 7. So in my calculator, I'm going to type that in, 125 over tangent of the 7-degree angle minus y, which was 125 over tangent 16. And I'm going to hit enter onto my calculator, and it does say to round to the nearest, I forgot what the units were, round to the nearest foot. That's whole foot. So to the nearest foot, when I subtract x minus y, I got that AD is approximately 582 feet. I'm going to put that over here, approximately 582 feet.